All right, hello everybody. I'm Junhua Zhao, a professor of city and transportation planning at MIT. This is the MIT Mobility Forum hosted by the MIT Mobility Initiative. Today is really my great pleasure to have Professor Paul MacDuffie join us from Wharton School of Management in the University of Pennsylvania. He will describe his research on the new paths for solving emergent problem of the electric vehicle sector. Before I formally introduce Professor MacDuffie, I do want to do some quick warm-up exercise, right? First of all, I do want to say that in this forum, we have a convention, which is everybody contribute one idea, right? So for all the audiences, I really encourage you to put in either one comments or one question in the chat so that everybody engage, right? The speaker often very much appreciates those type of comments and questions. So please, I invite everybody to contribute in this, right? So given the topics on electric vehicle, here I'm launch a simple poll for people to try, is to look at the EV purchase intent. To say that if you were to buy a car within the next 3 months, what would you buy? I mean, this is not a scientific kind of inquiry, just for get a sense of what people might state here. Okay, we have 70 people participated. I'll give 5 more seconds. Okay, so there's 96. I'll end the poll, I'll share the result. 97 people participated. 58% people said electric vehicle, 42 said ICE. Hopefully, Paul, hopefully that gives some context for you for this audience here. The second one is I encourage everybody to type in the chat your organization, your city. So I would say MIT, Cambridge, Massachusetts. Also, hopefully that gives some context for this Paul here. All right, thank you for putting your context there. So let me introduce Professor Paul MacDuffie. Is a professor of management from Wharton School in the University of Pennsylvania. He's the director of the program on vehicle and mobility innovation at Wharton's Mack Institute. His research examines vehicle and mobility innovation, the diffusion of lean production as an alternative to mass production, the impact of distance on managing human and social capital, the relationship between product and organizational architecture, and how the interaction of strategic choices with industry structure affects the competitive dynamics and industry evolution. His publication appeared in the top academic journals from a wide range of domains, such as the Global Strategy Journal, Human Relations, Industry and Corporate Changes, Management Science, and Harvard Business Review. And his commentary also featured in New York Times, Wall Street Journal, and the National Public Radio, etc. He's the founding board member and currently the president of the Industry Studies Association. He's a co-curator of Automotive Transformation Map of the World Economic Forum and a former member of the Automotive Expert Group at the Federal Reserve Bank. Without further ado, I'll pass the forum to Professor Paul MacDuffie. Please.
Thank you very much, Junhua. It's a great pleasure to be here with the MIT Mobility Forum. I have long and deep and affectionate ties to MIT, as I'll mention briefly, and it's a pleasure to see some familiar faces and also to encounter the audience that you have grown for this forum. Let me share the screen and get us started. Okay, I think it should be coming. All right, can we see, can everybody see all right?
Yes.
Great. Okay. So here we go. I got my doctorate at MIT School, as Jim mentioned, and was recruited outside an elevator by Mr. Jim Womack, Dr. Jim Womack, to join the International Motor Vehicle Program. So that's how far back the roots go and the ties go. You should understand how PVMI, this program at Wharton, has its roots in IMVP. This is how we would always describe IMVP back in the day, and how IMVP became a network of faculty and doctoral students around the world. It moved away from just being MIT-centric. These researchers often did projects together as well as keeping each other informed. And of course, the most, I think still the largest, most visible accomplishment of IMVP was the book, The Machine That Changed the World, with Dr. Womack as its lead author. And but there was a large community of researchers that participated in that, and that I would just speak for myself. My career was changed, transformed by that experience, and I still feel very lucky and grateful for that. So PVMI is the new name and provides the new direction for the IMVP network at Mac's, Wharton's Mac Institute of Innovation Management. My little inside joke for those in the know is that PVMI are the reverse initials of IMVP. So with that, let me just make clear that PVMI, and probably all of you, are not just paying attention to electrification, but all of these changes that are going on. I've just chosen the sort of CASE acronym here to talk about all the things going on. And of course, we're interested in how these things intersect. But for today, I'm only talking about electric vehicles. And I will say usually EV, but I will always mean BEV, battery electric vehicles. I know there are plenty of other sources of electrification of transportation, but I won't be going into the possibilities, for example, of hydrogen for trucks and buses and maritime and the like. This is really looking more at the passenger vehicle market. So many, for a long time, have talked about the barriers to the diffusion of EVs, and I've just sort of simplified that to a goal of achieving cost and performance parity with legacy internal combustion engine technology in order to really see diffusion take off and reach the kinds of emission reductions that feel urgent to those of us who are paying a lot of attention to climate change, but maybe less urgent to people who have different views on a topic. So the barriers to be overcome that I'm going to address today: the need for battery innovations, access to charging infrastructure, and affordability. I conferred briefly with Jinhua and decided that I should probably try to keep my remarks to the first two of these three, given how many slides I have and the limits of our format. But then he will probe on the topic of affordability. Maybe if I go really fast, no. Let's wait and see. I would say, and this was sort of the abstract for my talk today, that and I guess this is my stance, that we move beyond questions that seem to dominate the EV diffusion discussion for a long time, which were whether it would happen and chicken and egg. It can't go anywhere. There aren't enough vehicles to support investment in infrastructure. There's not enough charging stations for people to buy the cars. So I think now we're really at a stage of when and how. And it's not that there aren't a lot of problems. I'd say they're still thorny, but more tractable. And in general, I see this as a time where there's a swarm of innovations, really fueled, if you will, by both the expanding EV supply coming from around the world and from the deeper engagement of traditional incumbent OEMs, and also the many forces affecting EV demand, many of which, it has to be said, are from public policy and from government urgency around moving towards emissions reduction. Some of these are highly visible, some are behind the scenes, some are private sector innovations, some are public sector innovations. I don't claim to know, more than a tiny percentage of what's going on here, but my sense, and what I'm going to show you some of what is convincing to me, is that taken as a whole, they yield some promising paths for addressing these problems. So thorny but tractable problems that can increasingly be addressed. So I think disruptive technologies often only demonstrate their biggest impact after a swarm of related innovations in technical systems and social systems and institutions that provide support for the change. And for EVs, as I said, I'm going to focus on these three areas. This is a sort of a list of topics that I set out to cover, and I'll cover some of them more than others in battery charging and affordability. I'm going to come back to this slide as I go through, so I won't linger on it now. So let me start with battery innovations. And what I'm going to talk about here is physical innovations. I do think it's interesting that we have perhaps a heightened attention to physical innovations as opposed to digital innovations. And I think that's very relevant to mobility, obviously, and promising as investment also goes into that area. New chemistries, new extraction approaches, new approaches to integrating batteries into the vehicle. I'll talk a little bit about recycling and deglobalized supply chains as well. Obviously, the headlines about shortages of EV battery materials grow more and more alarmed as the demand seems to rise and people start taking a look at this. And given that the dominant battery chemistry has been NMC, or for nickel, manganese, cobalt, which of course has lithium. Lithium ion is the basis of all these chemistries, whether it's in the nickname or not. And then of course graphite for anodes. So I just have a quick characterization of one current state way of looking at each of these. That cobalt, very scarce, concentrated about half in the Congo. There's a lot of problems with the way mining is done of cobalt in the Congo, and this worries everybody who's interested in the growth of the battery market. Nickel, also scarce, concentrated in those countries, and some of the new formulations are using more nickel and less cobalt, it must be said. Nickel prices, all these prices are highly variable as commodity prices are. Nickel prices have actually been going down for a while. People are watching Indonesia, which says they may form a sort of a OPEC type group to try to manage the price of nickel. Graphite is not scarce, but concentrated. There's both a natural and a synthetic type of graphite used for anodes, and China is dominant there. So given some of the current geopolitical dynamics with China, not just with the US, but worldwide, that's a concern. Lithium, which is, of course, super important, is not really scarce, as I understand it. Supply is very much lagging demand at the moment. The prices of lithium have been crazy this year, 400 to 600% increases. But that's in relation to current supply and demand. The surface mining method that's been most commonly used certainly has some negative environmental impacts, and that concerns people as well. I mean, this USGS chart I have here is a few years old, and for example, it has reserves on the right. My understanding is that there are considerable potential reserves in the US, but they're obviously not such that they're labeled very much here. You can see that there is a lot of reserves that haven't been tapped yet in countries like Chile and Argentina, although Australia has tapped much more of their reserves. I would say if you look at sort of the academic research or the expert commentary on these kinds of topics, you of course find different views, and I think sometimes it's based, of course, on different research questions, different methods, different intentions, but I also think different time frames. So this, out of a recent New York Times article, talks about critiques of BEVs that focuses on where does the electricity come from, what about the emissions when you build batteries, et cetera. So you've got this Leibniz Institute study, which says a diesel from Mercedes has less greenhouse gas emissions than a Tesla Model 3. Professor of engineering at Cambridge saying, not only will it overload the grid, but the world doesn't have enough raw materials. And then a counter from this researcher at Eindhoven who says, no, batteries are lasting longer than we thought. Gas and diesel engines pollute more than we thought. Energy needed to create batteries has already declined. Energy production from renewable sources is growing. Again, I can't claim to be exhaustive on keeping up with this research, but I would very much agree with Dr. Hoekstra in terms of how I see the research reporting this out. And what I want to cover briefly are the swarm of physical innovations in batteries and their components, and of course software, but I would say I'm going to focus more on the physical innovations, looking beyond cells, chemistry variants, packaging innovations, platform flexibility, and then the software that manages battery systems. So cells have, they're the starting point. They have been a big focus of innovations in cell design and manufacturing. Tesla, to much fanfare, has released the 4680, the latest cell design, that they developed with Panasonic. You can see how much bigger it is. It has a number of advantages in Tesla's view. But I'm going to argue that really some of the other changes happening in batteries are more significant, maybe strategically. Cells have been put into modules and into packs for the longest time, even within these three categories of different types of battery packs. Now we see innovations there. We also see a trend towards vertical integration for batteries from really both incumbent OEMs and de novo battery electric manufacturers. I'm going to show you some data a little bit later about how this actually has some employment impact, certainly for the traditional OEMs. The different battery chemistries offer trade-offs and different supply chain solutions. So, I mean, part of why this caught my attention is all the focus on the problems with cobalt and nickel. You know, to see some chemistries that basically steer around cobalt and nickel entirely, and to find that they're feasible and are being implemented already, I thought was important. And so the LFP for lithium ferrophosphate, lithium is of course essential, and as I said, not scarce, but currently in short supply. But ferro, iron, and phosphate are in no way in short supply, and they're cheap. And LFP has some advantages and disadvantages, which I'll cover in a moment. But look at also what's happening with nickel, manganese, cobalt. Because of the problems with cobalt, the formulation of that from LG Chem has gone from 6-2, 6 parts nickel to 2 parts manganese and 2 parts cobalt, to 8-1-1, 8 parts nickel, 1 and 1 for manganese and cobalt. And of course, that puts more pressure on nickel, but at least gets you away from cobalt. So this kind of innovation, I think, is extremely important. And there's no convergence yet, I think, on a dominant battery chemistry. And to me, that's good, because we're still in a period where that swarm of innovations is really important. Packaging innovations, I also want to highlight. So more and more battery makers are looking to eliminate modules and go straight to a cell-to-pack design. And then the next step beyond that is to go straight from cells to chassis. And both of these innovations save weight, they save processing steps, they increase power density, which is very important to compensating for ways in which the chemistries are different. And a way to avoid the weight spiral, you have more weight in the vehicle and you need a bigger battery. The bigger battery weighs more, then you have to, the spiral continues. A little bit more here on cell to chassis, which is maybe the newest development. I like this analogy that Tesla uses when they talk about it, which is airplane wings now are designed to hold fuel. So you had to think about designing the fuel tanks in the shape of the wings and having them, be both part of the same structure. The analogous step is to design the chassis with a battery pack shaped cavity. And, Tesla, for example, and others are talking about now you use glues, which are already part of keeping the cells and the plates together, but you use an adhesive that has more structural strength. So now the glues become part of making the cell to chassis give the structure this double function. Leap Motor is one of the new Chinese EV manufacturers, and they're boasting that they're going to be the first to bring a cell to chassis product to market with this goal. The ultimate battery would have 100% active material. Everything would store and release energy, nothing wasted. GM, of course, has gotten attention for its Ultium battery platform developed with LG Chem, and the idea that, hey, we're going to design and choose the shape of different battery packs based on the type of vehicle, based on what works best for its size, its weight, its energy requirements, its aerodynamics, its stability, etc. And so, although we haven't seen a lot of these vehicles in the market yet, we will soon. And again, to me, there were ideas, I think now well in the past, that maybe there would be sort of standardized batteries for EVs, and you could do models like battery swapping, which would mean you could lease batteries and people wouldn't have to own them. You may remember the startup A Better Place. Even then, I was deeply skeptical that there would ever be the potential for just one battery design, given the vast array of vehicle types and the vast array of different design choices that have to be made in product development. Cell to chassis and configurable platforms are no panacea. They solve some problems and create others. Imagine if all of your cells are glued into this cell to chassis structure, pretty hard to replace faulty cells. These idiosyncratic pack shapes that GM Ultium will presumably have for GM models won't probably be transferable across other models. Will that affect scale economies negatively or create less repair or replacement flexibility? And some people are saying, look, these batteries at a certain point aren't so useful in the vehicle, but there's a lot of second life applications. Maybe these types of batteries won't be as flexible in their second life applications. For example, maybe they'll only be good for grid storage applications. Battery management system, the software, this is a whole topic that we could talk a lot about, but I think the main point here for me is that when you go to a different battery chemistry and different packaging options, you can tweak the battery management system to make that combination work better to deliver the power and the recharging characteristics that you need. And so software becomes very important, and some of it's also other parts of the vehicle as well. And you may change the programming of the way the HVAC system works, because with battery chemistries that have less power density, you may not want to do as rapid a increase or decrease of temperature in the HVAC because it drains the battery too quickly. So you use software and new HVAC designs to make all of that work. I just thought Leapmotor's statement about how they approach intelligent power systems, their intelligent power systems, is interesting because it's a statement of entirely vertically integrating everything and trying to innovate within that. We develop our own battery pack, our own battery management, and we're going to be the first to do cell to chassis. Frankly, this move towards vertical integration for batteries, and particularly beyond the cell, for the e-drivetrain, for the battery pack, for the BMS, is what we're seeing across the industry from incumbent OEMs and from de novo EV startups. I have a new paper coming out with Mark Elishay and Christoph Midler of Colt Polytechnique, and we gathered data from these 22 manufacturers around the world, including incumbents and some de novo. And so the column that's circled in red is the cells, and you could see there's a lot of buying of cells, but when you move to the modules and the battery packs and to the battery management system, now you have much more a make or some kind of close alliance with a battery maker or some other kind of collaborator. So it's supported that this vertical integration is the trend that we're seeing. Taken as a whole, the point I want to make here is that LFP, this lithium ferrophosphate, is a worthy competitor replacement for NMC. It started off being applied in scooters and small EVs, but it's now in a lot of other vehicles. Tesla has been using it in their Model 3 in China, and apparently will introduce it in the Model 3s made in the US. It's not a new technology at all. And guess what? Besides its advantages in terms of materials, it's much safer. There are no fires with this chemistry. There's lower toxicity. It does have lower energy density, but that's where these innovations in packaging innovation and battery management system software adjustments can help. Oops, what happened? Okay, here we go. I don't want to be Pollyanna-ish about solving the shortage of raw materials, and this is a quite recent and quite detailed look at, what can we expect of LFP batteries, what can we expect of NMCs with this new chemistry. What the automakers say they'll sell is higher than some of the projected sales. It's not going to be solved certainly quickly either, but shortages have their own role in the evolution of this sector. It's going to drive more expansion of lithium production. You're just scratching the surface of available reserves for lithium. There are new methods of lithium extraction gaining ground, such as direct extraction from brine. We've got the shifts even in the dominant chemistry of NMC. We've got LFP. And then we've got recycling. Recycling becomes more attractive as the raw material prices go up. I found this, thought it was a very interesting graphic about all the mining all the metals that are mined worldwide. And it's really hard to see, but if you look at this sort of aqua blue category of energy batteries, you can see lead, and but you can also see over on the left, nickel is there actually, although EVs is not its primary use, steelmaking is. Over on the right, you see lithium and cobalt and cadmium. But the point is, I mean, sometimes when you read about the concerns about, how are we ever going to have enough of these metals, it conjures up an image that we're doing a lot of it and it's just not enough. The only point here is that it's not really that much yet. And of course, it's all relative to reserves and the like. Investment is pouring into EV recycling, lots of players, an emerging value chain. And of course, as the higher raw material prices drive investment in recycling, if the capacity grows sufficiently, it should reduce the dependence in the future on new mining. Okay, so that gets me to charging innovations. And Jinhua, tell me, should I plunge ahead?
Sure, maybe 2-3 more minutes.
Okay.
Yeah.
Oops. All right, so with charging, first of all, to just make the point off the bat that electrification is urgently needed for transportation. I think this is an audience that understands that pretty well. And we've seen dramatic drops in alternative sources of energy. Here, 90% drop in the cost of solar PVs and the cost per kilowatt hour of lithium-ion batteries, 70% decline in the cost of wind, and that changes a lot of things, including politically how easy it is to make other kinds of policy changes. The idea that the charging infrastructure is now an urgent matter that comes front and center, I think clarifies a few things. We've got these different spheres for charging. Home, where the actor is the homeowner, the charging is overnight, the duration is long enough to be able to use not such a high-powered circuit. 220 is usually enough. Finance, usually by the owner or indirectly by paying rent. And it can be tied into making changes in an overall home grid system with solar panels and the like. Around town, you've got different actors, probably municipalities and businesses, charging during the day mostly. If somebody's parking all day while they're at work, it could be as long as 8 hours, but if it's people doing errands, it could be much less. Looks like this will happen through either purchases or leases of chargers by businesses and municipalities, and they're doing it to offer a perk to citizens, to customers, to employees and the like. And then, of course, you have highways, and here I think the federal government is going to be the big actor. It's on road trips. People don't want to wait a long time, so superchargers are more relevant. The financing, I think, will primarily come from the federal government, and the goal is to drive down range anxiety. There are going to be subsidies of all these things, and that's more clear immediately from the Inflation Reduction Act and the infrastructure bill passed in the US, but we're also seeing that globally as well. So many grid investments and enhancements are needed and smarter grid policy, but again, I think there's a swarm of innovations here. One that I'm aware of because a former student of mine is working on it at the interface between Con Ed and General Motors, is the need to do load disaggregation. You have to, if you're actually going to apply a pricing incentive to how somebody's using electricity to charge an EV, and often the people who are approving of these subsidies or these incentives want to know that it's actually going for EV charging. You have to be able to disaggregate the different uses. And that's a smart meter application, but it's something that you can actually fine tune to really pick up EV charging as opposed to other things. That's new and I think interesting and promising. You also have questions about when should you be encouraging EV owners to charge? And there's this new study from Stanford, which just looks at California, which of course has a lot of EVs and a lot of EV growth and also has a lot of solar power. There, the cheapest prices for electricity are during the day, late morning and early afternoon. At nighttime, you really start to need some storage. So their whole claim is, hey, instead of focusing on overnight as the time to incentivize charging, incentivize daytime charging. So, these are the kinds of debates that are playing out that I think are really interesting and important. Ideas in politics will matter. And maybe this is a good place to wrap up. I think if as and if electrification for home and transportation is understood, accepted, and supported, home charging will become more of a normal choice, an easier choice, and subsumed in a broader idea that you want to have a decentralized smart grid that supports you at home, potentially during power outages or with lower electricity bills or with more independence from the grid. And that will help home charging grow. If that electrification is also linked to visible cost savings in your vehicle ownership, but also things like new jobs, good jobs, new opportunities, growth in domestic industry, manufacturing, employment, et cetera, political support is likely to grow. And that's important because all of these steps towards electrification can be politicized, and that can cause a barrier. I'm somewhat encouraged by Tuesday's election results to think that there won't be quite as much political ability to push back on this recent legislation passed in the last couple of years. I do worry about jurisdictional disputes over all the electrification infrastructure steps that need to be taken, whether it's charging infrastructure or grid enhancements. So the hope is that that gets tackled at the same time. So you have streamlined and facilitated permitting. You train up the new jobs, the new occupations, the new firms that are gonna really do all the installation. As you see the visible changes in the build infrastructure, hopefully you get political support that keeps the momentum going. So, good. I'll stop there and then go to questions.
Great. Yeah, thank you so much, Professor MacDuffie. One good thing about this forum is in the audience, I often find very relevant personnel and expert in this. First, I want to acknowledge that Professor Dan Roos is actually in the audience today, who is the founder of the International Motor Vehicle Program. And also, I will also invite Jim Womack, who is the lead author of the book, The Machine That Changed the World, and also John Moenzati, who is the executive director of Mobile Initiative, who also have been interacting with Professor MacDuffie very much in the World Economic Forum. So I actually invite Jim and John each to say a few words about your reflection on John Paul's presentation. Jim, please.
Okay, there we go. Well, John Paul, it's been a while since we talked. I was struck by your memory that I recruited you outside the elevator at MIT. The method I normally used was to recruit people inside the elevator, between them and the door. So that makes me think you didn't need much persuading. And that's a good thing. Glad we didn't work together all those years under duress, but in a reasonably voluntary sort of way. And delighted to know that we're both still on the case. I'm a generation ahead of you, and so I'm glad I'm here, and I'm glad you're there. And let's keep on keeping on. I did want to say just a few things about the problem of the timing of all of this. That there is a kind of lock-in on the notion of 2035, 2050, zero net CO2, which, by the way, may simply be what the climate demands. I don't know. But it creates a certain sort of panic as those who are kind of watching this go forward, this transition, that we aren't making it. And I think there's also a sort of expectation that making it is a linear process. And I think, I don't know about 2035, 2050, the real needs of this planet's climate, but I do know that a linear process is pretty unlikely, that an awful lot of things are being tried. Some are not going to work, and people may find that at least briefly dismaying. Some are going to work better than we thought. I think collectively they're going to work well enough, but I am perplexed at the timing. Just to take something simple, that you could dramatically increase lithium mining capability if you simply relax all the environmental constraints. It takes, I don't know, 10, 12 years to permit a lithium mine in the US. How about 10 or 12 days? Well, that's just deeply horrifying if you think that you've got lots of time. It looks different if you think we have to really go fast. And so I don't have an answer to that, but it often becomes a sort of background noise of politics. is simply differing assumptions about how much time we've got and how quickly things can be developed. I myself have been looking a bit at the charging infrastructure, which is not very good. And here's another sort of goes back and forth, that the industry has been involved in what you might call a range race, which is to offer vehicles with these very long ranges, which implicitly presumes A, that the charging system is terrible, and B, that most people will use an awful lot of do a lot of their charging on the charging system. My view is that those are worthy of discussion. I have myself, I can confess this, I have a Rivian, which is a mighty fine vehicle. That was an advertisement. I'm not a shareholder, so therefore it wasn't really an advertisement. But I am struck every time I get in it with the fact that it weighs 7,200 pounds. How can this be a green vehicle? And it has a, honest to gosh, 315-mile range. I don't actually need a 315-mile range. So I'm lugging around a couple of tons of batteries that, okay, fine, maybe there's some green electricity there, but that's not an ample supply. So there's another dimension to the debate about charging, which is, do we need better charging or bigger batteries? And there's a lot of, confusion about what we're trying to do there. So look, this is a fascinating time. John Paul and I both went through the kind of trough in the car industry that we got to 1990 with the IMVP done. And for about 15 years, it seemed to me the big issue in the car industry was how many cup holders and where should they be located, which was deeply boring. I moved on to other things. John Paul moved on to some other things. And we have now come back around to this incredibly interesting time. So, hey, it is great to live in interesting times, presuming that it all turns out okay.
Great. Thank you, Jim. I'll invite John Moenzadi to add some remarks, and then Professor MacDuffie to offer some response together. Yeah, John, please.
Thanks so much. My comment reflects a bit on what Jim just said, which, maybe two really important points. Number one, the dirty little secret of electric vehicles is that they are heavy, and they are heavy because the batteries are heavy. And so we're expending a very large amount of energy to move around this battery. Now, we're already expending a very large amount of energy to move a vehicle around that weighs 10 to 20 times the weight of its occupants. So the automobile from the beginning has that fundamental design flaw, but it is a concern. The second comment is just related to also something I think Jim alluded to, which is scarcity. And, John Paul, I really liked how you said, when resources are scarce, economic actors will move to increase supply. And we can expect that will happen. But reflecting a little bit on Charlie Fine's concept of clock speed, when you look at the clock speed of the automotive industry and the market versus the clock speed of the mining industry, we have a disconnect there. So I think, we are in for potentially a little bit of an electric vehicle train wreck in North America when we just can't find the materials that we need for the batteries. But I'd be curious if you have further reflections on how that timing issue of the supply of the materials plays out in the short term, the medium term, and the long term. And then finally, John Paul, one of the things I learned from working with you at IMVP and at Wharton for 3 years was the concept of vehicle architecture, which you used to talk about a lot, and how the automotive vehicle architecture, is it a modular architecture, which at the time many automakers were trying to strive for, or is it an integral architecture? And your point at the time was, cars are more integral. Cars are not computers. You can't swap out these different components. It is a more integral architecture. And just reflecting on some of the things in your talk, this concept of cell to chassis, that's as integral as you get. So I would be curious if you have reflections on, the battery swap model famously proposed by better place many years ago. Now some companies like Ample are pursuing that similar model. If you have any comments or reflections on that. But thank you very much for your talk today.
Thanks, John. Professor MacDuffie.
Sure. Well, on the scarcity and the timing issue, I think it's an interesting framing what Jim said about the race to bigger batteries and higher range as the way the industries initially wanted to deal with the range anxiety concerns, without looking at the complementarities with charging infrastructure and that there might be different combinations. Also, we not only have very expensive EVs, but we have larger EVs. We have the heavier, larger, more luxury end of the vehicle range is what we've seen so far in the US. And affordability, the third topic, is very much tied to there being, other sizes, other types, lower priced vehicles, where the weight and battery size and charging complementarities might be designed very differently. With respect to the timing with raw materials, I'm not enough, I don't know enough to say very much. I guess my hunch is that with all the innovation around battery chemistries, which can go towards different minerals, with the innovations in packaging ideas that reduce weight and increase power density and make new chemistries possible, with some greater urgency around the availability of the materials that is also driving innovation in extraction techniques. My understanding is that the direct lithium extraction from brine, I don't know how close it is to feasibility, but it has quite a low potentially environmental impact compared to the other methods. And so again, if there's more investment, if there's more, upward price pressure on innovating, and then again, I don't know how to evaluate the potential for recycling, but certainly some of the claims I've seen suggest that, the more the high cost and delay in mining new raw materials goes up, the more value there is in innovating and doing more with recycling and getting that back in, as well as, and by that I mean, in a circular economy sense, both second and third life uses of batteries before they're really taken out of service, and then ultimately the recycling and return of the materials back to the start of the chain. So it's kind of a hunch, and I do tend towards optimism when I think I can. So I can't. I probably would say you should recognize a dispositional bias in the way I talk about these things, but I guess we'll see. And that set of innovations happening at the same time, and along with the forces pushing up demand and pushing up supply, is why I have that view. I do want to say something about this. Is the architecture modular or integral? John, you're absolutely right. It's because I led a big global IMVP team looking at modularity initiatives in the auto industry in the late 90s and early 2000s. And they started with great fanfare, and within 5 years, they all were completely wrapped up and wound down, and you couldn't find any mention of them again. And that was disappointing to all of us who worked on that project. But after thinking about it for a couple of years, I decided, like the dog that didn't bark, the real significant finding was that it didn't work. And that it told us something about automobiles having this integral architecture. People have predicted that EVs are going to be much more modular. Increasingly, there's some evidence that may not be the case. Again, in this special issue of Industrial and Corporate Change that's coming out soon with the paper I have with the French co-authors, there's some German researchers who actually got a couple of companies, some traditional automakers and some de novo EV makers, to fill out a DSM, a design structure matrix, to show the interdependencies between different subsystems in an electric vehicle versus an ICEV architecture. And they actually found, at least at the moment, in these two different firms, more interdependencies in BEVs than in ICEVs, perhaps reflecting an early stage. But all these systems are being redesigned somewhat simultaneously to optimize performance of EVs, given battery concerns, weight concerns, et cetera. And that just makes it a more integral process. And of course, that also leverages the existing capabilities of automakers. The de novo, BEV makers are mostly populated with people who have background in that industry. There's a lot of people coming from other industries who would love to see BEVs be entirely modular with skateboards and interchangeable chassis. I just haven't seen it yet. There may be some very narrow vehicle purposes for which that can play out. But to me, also, if it's already still a very integral architecture, if that's where the capabilities are and that's where innovation possibilities are, then I say, let's go for cell to chassis and deal with the disadvantages of it, because it helps solve a bunch of other problems and it's more attainable in the short term.
Great. Yeah, thanks, John Paul. There's a lot of questions in the chat from the audience, so I will limit my question only to the last aspect. We discussed the battery, the charging, but we want to make sure to cover the affordability at least briefly. On that, to say that the two related questions. One is what are the dimensions of affordability and equity we're talking about, right? So, for example, obviously between rich and poor, but it's also an important dimension between urban and rural. Right. And the third one, even between the car owner and the non-car owners, right? So those are different dimensions of equity and affordability we're talking about. And then in terms of the solution, so it's whose job to really be responsible and offer a possibility to engage in different dimensions. Is the federal government through the Inflation Reduction Act? Is the cities? So who should play a role to really address these affordability questions?
I mean, I focus most of my attention on the development of a used EV market. And as we have more supply of new EVs, we will eventually have more used EVs, right? And so far, the used EV market in the US is mostly Teslas and a few of the early models like the Leaf and the Volt. And so the average price is still quite high. That market is going to grow by virtue of, as I say, more new vehicles and more different models. But the Inflation Reduction Act of the federal government is trying to give it a push in the right direction by allowing for the first time tax credits for used vehicle sales. There are a bunch of rules around it, and there's some purchase price limits. So it won't include a lot of sales, people getting tax credits for selling their Tesla Roadster or their Model S. It's confined to lower price vehicles. And also plug-in hybrids are included for the first time in that. And plug-in hybrids, I think, are perhaps an undervalued category. There aren't so many models there. There have been some critical assessments that, people drive more with the gas engine than with the battery, and so they're not so good environmentally. But think about it, they are a kind of gateway. I don't want to say drug, because I don't know if that's the right metaphor. They're a gateway to people being used to electrification, being used to charging, and they're accessible to people who don't have access to charging infrastructure now. People who live in cities, people who may be poorer or, just don't have that access. So I think to encourage the used PHEV market by including that in all this and getting on people's radar screens, and there may actually be more PHEVs that come into the market, I think is one of the good signs. I don't know if I can get to your other topics right now about urban versus rural, but I think a strong financial nudge, using the federal relatively progressive tax system to provide the tax credits, getting it that you can get it, when you buy, right off the top. All those things are little changes that will really help.
Great, thank you. Yeah, so I want to give the last 10 minutes to John for the Q&A from the audience. John, please.
Super. Okay, thanks so much. And as always, we have a ton of questions popping up all in the chat. So,
Sure.
So John Paul, why don't I start? Yeah, that's right. Why don't I start with a question from Alex Curtis, which is, would a deglobalized supply chain for battery materials imply that automakers in different countries have different kinds of batteries? Thus, there not being a kind of standard battery design. Do you have any kind of early signals on this, that we could have like these regional battery markets?
It's a good question. I think you'd want to look at whether deglobalization usually means going from global to regional, right? And so, and sort of nearshoring and friendshoring, well, let's just say nearshoring. You'd want to look at where the distribution of the minerals are. And if you imagine that more extraction is going to happen, does it mean that in each region you don't have access to those minerals? That would be important to understand. But I already don't think we're headed towards standard batteries anytime soon. And these different chemistries are in many ways suited to different segments. So if, in Europe, vehicles tend to be smaller, the LFP seems to be a chemistry that's more promising with smaller vehicles. Maybe that means there's going to be more LFP in Europe. There's already a lot of LFP in China, where there is a large and growing small vehicle segment. But maybe there'll be advances in LFP that work with bigger vehicles in the US. So I guess I don't think that geography and deglobalization is going to drive battery design as much as these other things.
Correct. We have another question from Roman Gauss, which is, please address how China or California have significantly higher penetration in electric vehicles than the EU or the US overall due to emissions regulation, introduction of ZEV credits, stringent penalties, charging policies, et cetera. So I think the question here is about, what do you see as maybe the top 2 or 3 drivers of ED adoption and penetration?
I mean, each of those stories is different, but it absolutely highlights the importance of government policies at different levels. Obviously, in California, state acting in many cases in not necessarily defiance, but having been given permission to have its own set of standards separate from the federal Clean Air Act and EPA regulations, has allowed them to pursue a set of goals consistent with their whole history of wanting to reduce air pollution and the like. In China, an awful lot of it was simply the fact that they wanted a globally competitive automotive industry, and they weren't succeeding with exporting of internal combustion engines. They saw a chance to leapfrog and be leaders with EVs. Of course, it has benefits as well in less air pollution in Chinese cities, but I don't think that was the primary motivator. I think it was more, we're going to leapfrog and we're going to, dominate the world in EVs and eventually export them. But first, their home market was the biggest place, and they could require that the foreign manufacturers there use their components, which boosted all their component industries. Norway is the country with the highest penetration of EVs, and they used absolutely every policy lever imaginable, starting with cheap electricity from hydro, but subsidies, dedicated lanes, preferential parking, every single imaginable thing with a big and obvious payoff. So, the EU started a little sooner than the US. US has been quite conflicted about how much to use policy to advance this. But to me, it shows that if you get a little bit of consensus around using a few policy levers, you really can speed up the EV diffusion at this point in time.
Right. Yep. So policy leads, and I think Norway was at 85% of sales last year were electric vehicles.
Yeah, new sales. That's kind of amazing.
Formidable number. Okay, we have a question from David Metz, which is more about, does electric propulsion fundamentally change the performance of the automobile? Seemingly not. I guess this is more on the kind of the customer perspective side. Are there things about electric vehicles that are just fundamentally different, better, worse than traditional ICE vehicles?
Yeah, I mean, a few of the obvious things, silent operation, incredible acceleration, no torque steer during that acceleration, something that appeals to people who are used to driving fast in internal combustion engines. Yes, there certainly are some, and of course it's often coupled now with, in Teslas at least, with the software, a different whole kind of operating system for the vehicle. But back to the vehicle architecture question, where I think the people who expected modularity to dominate in electric vehicles had it a little bit wrong is, sure, the drivetrain, the motor, the fuel source is hugely important. Maybe it's the most central component. But there's a ton of other subsystems and technologies in a vehicle. It's a technology product. It's an incredibly complex product that don't really change with electric vehicles and still have to be part of the product development process. And that's where this integral nature of automotive vehicle architecture, I think, doesn't really change. Then when we find that you can, both in design and in production, you can build internal combustion engines and battery electric vehicles on the same assembly line. There actually aren't very many operations that change in order to do that. I mean, that drives some aspects of how production is designed and components are designed. But so I think there are some visible parts of driving that are different and that are marketed to people, as well as the lower cost of ownership and the other contributions. From the industry's point of view, in terms of design and production, I would argue there's less revolutionary difference. There's a tremendous amount of evolutionary difference. Evolutionary changes are something that the global automotive industry is actually quite good at. And so that gives me confidence that the incumbent OEMs have as big a role in this transition as the Teslas and the de novo startups.
Super. Okay. One more question from Elena Renda, which is referencing a recent study that demonstrates that keeping older, fuel-efficient internal combustion engine vehicles on the road longer reduces CO2 emissions significantly more than replacing them with electric vehicles. I guess the study, Nakamoto was the author. Have you heard of this, or do you have any sort of thoughts or reactions, reflections to that study?
Yeah, I mean, I haven't heard of it. It strikes me as being a bit in the short-term, look, where what weighs against the battery electric vehicles is the fact that you're looking at their electricity coming from coal plants or some other things about battery production. And yes, there are some wonderful, very fuel efficient internal combustion engines. I mean, there's been innovation, this idea of a last gasp, right? This old technology, or this still around technology, has also innovated in these important ways. But what I end up getting to on affordability as well is, the older, dirtier internal combustion engine vehicles are going to be the easiest port of entry for a low-income purchaser. And those have so many disadvantages. They pollute more, they use more fuel, they don't have as much safety equipment. I can see a lot of reasons from a broad public health and public good perspective of getting those vehicles off the road and getting people into either a recent model, very fuel efficient ICE EV, or an inexpensive used EV or PHEV. Cash for clunkers and similar kinds of policies have a mixed record in terms of what their actual impact is, but I think it may be a time for some really creative policy making around that idea, because like so many other things in climate inequities, you end up saddling some of the poorest and least advantaged people with the worst vehicles and the most negative consequences for both their finances and their health.
Mm-hmm. Time flies by. So I really appreciate Professor MacDuffie joining us, sharing your experience, and also the conversation afterwards. So everybody, please join me. Thank John Paul for the presentation. It's really great.
My pleasure.